Hello everyone. Today I want to talk to you about some of the energy sources that we're using for powering particularly our electricity, and talk about some of the returns on investments that we can get, as well as some of the other costs of using these types of energy. So this first figure is figure 1026 from your book, and it's talking about how much water is consumed in the process of generating or using these types of primary energy sources to get electricity. And so you can kind of compare some of the more renewable types of techniques for getting energy in the form of electricity compared to other primary sources. So here you have solar power, and the book talked about how much water is consumed in the process of trying to gain energy from the sun in order to produce electricity. So we have quite a bit of water being consumed. So we have to balance, okay, we are getting a great primary energy source from the sun, but now we have to use another resource in order to get it. So this is one of the major drawbacks still of using solar power, and an area where we have to definitely increase our technology to be able to use solar power more efficiently. When you compare that to how much water is used in the process of extracting and then refining the fossil fuels, you can see that fossil fuels just make sense as far as money and resource consumption goes when you look at this type of chart. So yes, there is more pollution on the other end, but yet we're using a lot of a precious resource. In this case, this graph is talking about water, in order to be able to get that renewable type of energy versus the fossil fuel energy. Then you can see some other renewables like biomass and nuclear also require either similar amounts or a little bit more, in the case of nuclear here, to be able to use these as a primary energy source. The next graph here is figure 1027 from your book as well. This is energy return on energy investment. So for how much energy you put in to being able to use this primary energy source, how much energy are we actually getting back out of it in the form of electricity? So you can see that hydroelectric, which is usually associated with dams, gives us a good return on our energy investment, because here you basically just have the flow of water already flowing down a stream, and we're trying to harness that to generate electricity. So we have a great return on investment there, because we don't have to put a lot of energy in, because the flow of water already has potential energy. Wind is quite a bit lower. As you can see, coal is kind of in the middle here. And then the return on investment when we drop to other less polluting types of fossil fuel like natural gas is really dropping off quickly. And then you can still see solar and nuclear are not quite stacking up compared to some of the others, because of the types of energy we have to invest. Not only in just producing the primary source, or getting energy from the primary source, which is the uranium here, but also in the hazardous waste and taking care of all the hazardous waste afterwards. So you can see that your return on investment can vary greatly depending on what type of energy input you're using. And also in the last figure, you can see that the amount of other resources required for this type of energy to produce electricity can also vary greatly from one to the other. And then lastly, again, looking at the same output, energy return on energy investment. So for how much energy I put in, how much energy do I get out? And here you can see conventional oil, the type of crude oil, gasoline that we refine for our cars, really has the best energy return on investment, compared to even some of these more what we call sustainable types of versions of that gasoline. So mixing it with ethanol from corn sources or other sources. Really, by doing that, because we have to harvest that other biomass to be able to mix it in to form the ethanol, we're really reducing our return on investment as far as energy goes. And then down here, corn ethanol is by far the least return on energy, with all the energy that goes into growing and utilizing that corn. So the overall point I want to make here is it really comes down to the bottom line, not only of money, which is what these energy return on investments are talking about. Um, if your best return is going to be from gasoline, then it makes sense that most people are going to be pushing for continued use of crude oil. It's not going away anytime soon, as long as the energy return on energy investment is this high compared to some of the other sustainable types of energy resources. And again, if coal and crude oil are high on the energy return compared to many of the other types of renewable resources that we have, then they're going to continue to be used. So it's hard for us sometimes to understand what's the big deal. Why can't we just move and shift over entirely to using these more sustainable primary energy resources? A lot of times it comes down to money, and of course we know that that's the answer. But also in some cases it's more than just money. Sometimes using that renewable resource for an energy source is also consuming other very important resources that we are just as concerned about, like water. So we have to take all of these things into consideration when we talk about what type of energy sources are we using for electricity. It comes down to money, it comes down to resources, it comes down to a lot of things playing into this. And really the way out is a lot of the suggestions that were made in this chapter 10 as far as moving forward with our sustainable resources, taking those suggestions into play, developing more technology, making sure that our technology is ever increasing so that we can get more energy return on investment for the energy that we put in for all of these primary sources of electricity.